couple examples where we have some transformations and we need to graph them. So we give you its original parent function. The parent function is an absolute value function. You remember I'm going to draw a quick sketch of this. Its critical point or vertex, in this case, is 0, 0. Then the next point is 1, 1, and then negative 1, 1. And then it goes off into a shape of a V. So just a quick little sketch without a coordinate plane. Now our new function is with the transformations. We have two transformations. Inside the function means it's going to go to the right 2. And then the outside the function means it's going to go up 5. So our critical point is right 2, up 5. And then I'm going to put that in our first xy plane, or xy coordinates. So let's graph that first coordinate, over 2, up 5. Then we create our ordered pair, over 2, up 5. Now, this is the function g of x, which equals the absolute value of x minus 2 plus 5. We're going to continue finding more ordered pairs to find that shape of that graph. So we're going to pick a point to the right on the x-axis and the left on the x-axis from point x being 2. So I'm going to just choose a new color. Let's choose blue, and we're going to have it be right 1, which is 3, and left 1, which is 1. And we're going to evaluate the original function right here for x. So we say absolute value of 3 minus 2 plus 5, and now we simplify that. Absolute value of 3 minus 2 is 1, absolute value of 1 is 1, add 5, and we get 6. Do the same thing for 1. 1 minus 2, an absolute value. 1 minus 2 is negative 1. Absolute value of negative 1 is 1, and we get 6. So we graph those two ordered pairs next. Over 3, up 6. Over 1, up 6. Choose two more ordered pairs to find. So we're going to go one more to the right. So now we're going to go 4. And then 1 to the left, which is 0. And we evaluate the function again for x. So 4 minus 2 absolute value plus 5. 4 minus 2 is 2. Absolute value of 2 is 2. And we get 7. We should get the same down below here. We have symmetry. Absolute value of negative 2 is 2. Add 5 is 7. We'll graph those over 4, up 7, over 0, up 7. Now we have our graph of our function with its transformations. Our second example is now a parent function of a square root. If we wanted to graph that, remember earlier this chapter, we would plug in 0 in for x and we would get 0 out. If we plugged in 1 in for x, we would get absolute or square root of 1 is 1. So just a couple points here. And it looks like this is its shape. We have two transformations. One of them being minus 5, that's going to shift it to the right 5. So our critical point is over 5, up 0. And notice there's a negative in front of this. This should reflect about the x-axis. So let's graph our first ordered pair, which is our critical point, 5, 0. Now we're going to pick a number to the right and a number to the left. So let's pick 6 and 4. And we're going to substitute it in for the red function. So again, it's going to be g of x equals negative square root of x minus 5, and you're substituting it in for x. So negative 6 minus 5. 6 minus 5 is 1. The square root of 1 is 1, and then we have a negative out in front. Go down and do the 4. So 4 minus 5 is negative 1. Square root of negative 1 does not exist. There is a problem as we move to the left on the x-axis. 4, 3, 2, 1, 0. All of those do not exist because you can't take a square root of a negative number. It becomes imaginary. So we're not going to turn any more numbers to the left of that critical point 5, 0. So let's graph now the order pair 6, negative 1. And now let's pick one more point. Let's try now another number to the right, which would be 7, and substitute it in. Seven minus 5 is 2. Square root of 2 is about 1.4, so we have negative 1.4. We graph that point over 7, negative 1.4. And you can kind of continue if you'd like. That's what the shape of the graph will be. There is the reflection going on about the x-axis.